All right, let's talk about one of the most powerful and honestly mind-bending ideas out there. It's a concept that explains everything from a flock of birds to, well, your own thoughts. We're diving into the theory of emergence, and it all kicks off with a really simple puzzle.
I want you to picture a single ant. Just one. On its own, it's not exactly a super genius, right? It's just a tiny biological machine following some basic hardwired instincts. You wouldn't look at it and think, wow, what an architect.
But then, you get millions of them together, and something truly incredible starts to happen. Suddenly, you have a colony that can build these incredibly complex underground cities, they can farm their own food, they even wage organized warfare. None of those behaviors are inside any single ant, so where does all that complexity come from?
Well, the answer is this amazing idea called emergence. And here's the gist of it. You can start with super simple parts, give them a handful of simple rules, and out of their interactions, you get this stunningly complex behavior that wasn't in the parts to begin with. The magic isn't in the individual, it's in the interaction.
You've probably heard this phrase before, and it just hits the nail on the head. That ant colony is so much more than just a big pile of ants. The whole really does become something greater, something different than just adding up all the pieces.
So, how does this magic trick actually work? Let's get into the nuts and bolts of how these simple, local rules can produce such enormous and complicated results.
It turns out there's a basic recipe, and you only need 3 ingredients. First, you need simple components. Think ants or birds or even atoms. Second, you give them a few local rules. And this is the key word, local. Each part only knows what its immediate neighbors are doing. It has no clue about the big picture. And third, you just let them interact.
One of the most beautiful examples you'll ever see is a flock of birds in flight, a murmuration. It moves like this single, intelligent, living cloud in the sky. But here's the crazy part. There's no leader. There's no one in charge giving orders.
So what's the secret? Well, each individual bird is following just 3 incredibly simple rules. 1, don't run into the bird next to you. 2, try to fly in the same general direction as your neighbors. And 3, stay close to the group, don't get left behind. That is literally it.
And when thousands of birds all follow those 3 tiny rules at the same exact time, this breathtaking, coordinated dance just emerges. The pattern itself is the more that's greater than the sum of its parts.
I know, this can feel a bit like magic, right? This leap from simple to complex. It makes you question the most basic stuff. For instance, think about water. It's just hydrogen and oxygen, 2 gases. So, where on earth does the property of wetness come from?
Well, a single molecule of H2O isn't wet. It can't be. Wetness is an emergent property. It only exists when you have billions and trillions of these molecules all bumping into each other, creating things like surface tension and flow.
Okay, so once you start to recognize this recipe, you see this pattern everywhere. And I mean everywhere. It shapes our entire world in ways we rarely stop to think about.
Have you ever been stuck in a traffic jam that just seems to appear out of thin air? No accident, no construction, nothing. Well, that's emergence. No single driver wants to create a jam. They're just following simple rules. React to the car ahead, try not to crash. But one person taps their brakes, and that tiny action can ripple backward until, boom, a phantom traffic jam emerges. It's the exact same idea behind something huge like a stock market crash. You have millions of individual investors, all just trying to make the best decision for themselves. But out of all those separate choices, massive patterns like market bubbles and crashes emerge, often without anyone being in control or even predicting it.
But now, let's talk about the deepest, most profound, and most personal example of all. Let's talk about you. Your consciousness, your sense of self, is arguably the ultimate emergent phenomenon. Because think about it. The basic building block of your brain is a single neuron. And a neuron is just a cell. It fires a little electrical signal. It doesn't have thoughts. It doesn't hold memories. It can't feel love or regret. It just fires.
But you don't have just one. You have around 86 billion of them, each one connected to thousands of others, all following simple chemical rules, just passing signals back and forth.
And somehow, out of that chaotic, crackling storm of quadrillions of interactions between these simple cells, you emerge. Your personality, your memories, your awareness, your entire inner universe. There's no single you cell in your brain. The you is the pattern.
Okay, so this idea obviously takes us into some really deep philosophical territory. So for our last section, let's look at what emergence means for things like consciousness, artificial intelligence, and our very understanding of reality.
Now, it's important to know that scientists talk about two different flavors of this: weak and strong emergence. Weak emergence is like a traffic jam. It's complex, sure, but in theory, we can simulate it on a computer and fully understand it based on its simple rules. But strong emergence, that's the really controversial one. That's the idea that some systems, and many people put consciousness in this category, produce properties that are genuinely new, that you can't fully trace back to the parts. It's a huge debate.
And look, this isn't just some dusty philosophical debate. It is happening right now, at the absolute cutting edge of the technology we're building. Modern AI, like large language models, are textbook emergent systems.
Let's use our recipe again. The simple components? Millions of digital neurons. The rules? Just simple math. The interaction? Letting it train on an unbelievable amount of text and data from the internet. And what emerges? The ability to reason, to be creative, to use language in sophisticated ways, abilities that the programmers never explicitly coded into it.
When you really grapple with this, you realize it challenges some of our most basic assumptions about the world. It pushes back on pure reductionism, the idea that you can understand something just by taking it apart. And it makes you ask some really tough questions. If our sense of self is just an emergent pattern, what does that mean for free will?
Which leaves us with one final, huge question to chew on. We know a flock of birds is a pattern. A traffic jam is a pattern. A thought is a pattern of neurons firing. So, what about the thinker? Is that constant, stable feeling of being you simply the most complex, emergent pattern we've ever encountered?